In the second Kong AI Gate and Amazon Bedrock video, I'm going to be showing two other use cases. The first one is related to semantic routing, where the AI gateway load balances the requests across multiple LLM models based on semantic policies. And the second one, I'm going to be showing how to use the request and response transformation plugins. This diagram here illustrates how the semantic cache use case works. First, differently to what we did in the first video, we are using the AI Proxy Advanced plugin. This plugin has the ability to implement various load balancing policies, including distributing requests based on semantics or similarity between the prompts and the description of each model. For example, consider that you have two models. The first one is being trained in mathematics and the second in classical music. What we want to do is to route the requests accordingly based on the topic each prompt has presented. What happens is that during configuration time, done by, for example, submitting declarations to the control plane, the plugin hits the embedding model for each description and stores the embeddings into the vector database. Then, for each incoming request, the plugin submits a VSS or virtual similarity search to the vector database to decide to which LLM the request should be routed to. Let's check the current plugin configuration now. On your left, you see connector control plane with all Kong objects created, including gateway services, routes, and plugins. On your right, you see Sonia, which is a tool you're going to be using to send requests to the AI gate. Let's check the route first. The route has got only one plugin configured, which is the AI Proxy Advanced plugin. First of all, the load balancer algorithm is set as semantic. Next, we have two targets defined. The first target has been restricted to route requests based on the topics described in the description parameter to the Amazon Nova model. The second target, similarly, will route requests related to its description to the Anthropic Claude 3.5 model. Finally, the plugin is consuming Mistral as its embedding model. Now, let's send requests to the AI gateway. So as you can see, the first request is related to mathematics topic. So if you send it, we are supposed to get a response coming from the Nova model, as you can see over here. However, if you send another request, this time related to classical music, we are going to receive a response this time from the Claude 3.5 model. Let's jump to the second use case now. So first of all, it's important to understand we want to consume a regular service. The thing is, we want to leverage the AI request transformer and response transformer plugins to transform the requests before routing them to the service and transform the responses before getting back to the consumers. Okay, let's see the plugins working now. First of all, let's check the route. The route exposing the HTTP bin service, which is a well-known echo service. The route has got three plugins configured: the rate limiting plugin, the AI response transformer, and AI request transformer plugins. They are configured but not enabled. Let's check the AI request plugin first. So the request transformer plugin is configured to take the city tag from the request and add another country tag based on the country in which the city resides. The plugin is going to consume the Anthropic's Claude 3.5 model to do it. The response transformer plugin is configured to take the upstream service response and add another tag, this time with the current temperature we have in our city. The plugin is using exactly the same model, which is Anthropic's Claude 3.5. Before enabling the plugins, let's send a request to HTTP service in order to see a regular response coming from it. So as expected, the responses got exactly the same data we sent with extra headers related to it. If we let's enable the plugins now. The rating team plugin, response, and request. Now we're going to send exactly the same request, and then we're going to see a very, very different response. So as configured, the final responses got, first of all, the country added by the request transformer plugin, as well as the current temperature we got in Tokyo right now. Tokyo as our city. The temperature was added by the response transformer plugin. Interesting enough, since we got the regular rating team plugin also enabled to exactly the same route, if we keep on sending requests to the AI gateway, eventually we're going to get the 429 error code, meaning that we have reached the rating team policy, as you can see over here.